Okay, we're going to build up the control part of our write-up today. Now, here's what you should be writing about in control. You're going to talk about your various treatment groups. You're going to talk about what the various treatment groups are, and then more specifically, you want to talk about how exactly they're going to get exactly the same treatment each time. So their environments are going to be the same. Okay? In this particular example, you're going to have two different treatment groups. One is going to get the beta blocker and the other one's going to get a placebo. And then go into more detail. Just mention a couple of things. How are you going to create homogeneous environments here in terms of the treatments that are given? You might say something like, if they're given a shot, I don't know how beta blockers are given, but if they're given a shot, the liquid in the shots would look exactly the same. They'd be given the shots at the exact same spot on their bodies. Okay, they would be given the shot at the same time before the surgery. Okay, you just talk about various things that you're going to do to make sure that those treatments, what the treatments groups are, and then that the treatments are distributed in exactly the same way. Okay, a couple of vocabulary words you're going to be using in that control group. One of them is called blinding. Blinding is what I was discussing right there. Blinding is when the person getting the treatment has no idea which group they're in. Okay, that eliminates some of the placebo effect, right? If I know I'm getting the treatment, it might affect me differently. So all this stuff about they're going to get the shot and the liquid's going to be the same, or the pill's going to be exactly the same. Those are examples of blinding. So in this particular experiment, you would definitely want to have blinding involved. You'd explain different ways you're going to blind the experiment. But quite often, you would take it even a step further. Not only would you blind the experiment, but you would double blind the experiment. Now what double blinding means is not only does the person who's getting the treatment have no idea which one they're getting, but the actual person working with the person, in other words giving him the shot or giving him the pill, they don't even know which treatment they're giving. Why? Why would we care about that? Why do you care if the person giving the treatment doesn't even know?
So they don't, like, they give it away by facial expression.
Yeah, like, you know, boy, yeah, this is a new cancer medication, and I know you're getting the treatment. It's like, yeah. And then I know you're not getting the treatment, and I would somehow suddenly give you that vibe, so you would know whether you were getting the treatment or not. So if you can eliminate that in any way, shape, or form, double blind it. In fact, you're going to get a problem later on where it's a new psychological technique, new psychology technique. And there's actually a way to double blind that experiment, so you'll work with that later. But whenever you can double blind something, in other words, the person doesn't know which treatment they're getting, but the person administering the care doesn't even know which treatment they're giving, do it. Now don't carry this too far. Some of you, it might be on your test, you're going to have a question dealing with fish. Half of you are going to blind and double blind the fish. No, we're talking about humans here with these particular words. Yes?
Is there such a thing as like a reverse placebo effect? Like you take two groups and give them both the treatment, but you tell one group that they're getting a placebo?
Whatever they think can have an effect. Absolutely. So thinking that they're not getting the treatment can have an effect. Thinking they're getting the treatment is going to have the effect. That would be a nice experiment to do if you were doing an experiment on the placebo effect. You know what I'm saying? But sure, I mean, either way, the mind can do things that we can't understand. Take it out as a lurking variable. That's what we're doing here, right? All three of these are taking different things, different lurking variables out. Okay. Two other things, just to keep your mind on now, just things about experiments. You can do everything right, but you still might not be able to predict the future. And the first one's lack of realism. An obvious one is, you know, rats. You know, so I do everything right. I randomly put the rats into different groups, and then I give this rat group, I make them smoke. Okay, and I pretend to make this rat group think they're smoking. Now, there's no blinding with rats, but I give these rats a bunch of nicotine, and I give these rats not, and these guys all get cancer, and these guys don't. But can we infer that onto people? No, of course not. We know it works on rats, but because the experiment lacked realism, okay, you can't infer it onto others. Another example of that, there was an experiment done, and so people thought, you know, I wonder if we added a light to a car, if that would help reduce accidents. So they did everything right. They got a random group of cars, the same make, and they did a lot of good stuff here in control, same make, same drivers. I randomly chose, and on half of the cars, I put a big light in the front and a big light in the back. So it was 3 headlights in front, 3 headlights in back. And the other half of the cars didn't have that. And they went out and they ran the experiment, and you know what? They found that the cars with the 3 lights had way fewer accidents. So can we infer that onto everything? Should we put 3 lights on every car because it'll help with accidents? What do you think?
Well, in there, you could say that there's a lurking variable in the fact that the third light is a new thing that drivers see.
Exactly. I mean, let's take it to the extreme. You're driving along and you see this car looks like a Christmas tree. There's 8,000 lights on it. Now, are you going to run into that car? No, you might run into another car because you're looking at the Christmas tree, but my point is that's going to get your attention and you're not going to hit it. Okay, well, what happens then when all the cars have 3 lights? You go back, it's not different, it's not a change, and you go back to the same effect you had before. Okay, it was the change that made the difference. So, I mean, everything was done perfectly, but because of the lack of realism in the experiment, you can't infer it onto all situations. And then finally, this last one on inferring conclusions. You make sure that when you do have a conclusion, you can only infer it back onto the population it was taken from. Okay? I've got this population of whatever. I randomly pick out of this population. I get statistically significant evidence that one thing's over another. Okay? Well, you can only infer those results back onto the population it was taken. For example, let's say I wanted to know how Elk Grove High School students were going to vote in the next election. So I go take a good random sample of all Elk Grove High School students and I get the percentage of who they're going to vote for. Well, then I can make a prediction based on Elk Grove High School students, but I can't make a prediction on all students in the United States then. Okay, so make sure when you're inferring your conclusions that you infer them back onto the population of interest. Any questions or comments about that?